All right, lesson 4, unit 4, chapter 6 on factoring. All right, let's warm up. All right, steps to factoring. I am noticing this is a 3-term. There's an x squared first term, and then an x, and then a constant term. So that is in the proper order for a 3-term. I am noticing that there is no number in front of the x. There's a 1 in front of the x that I don't see. So I consider that kind of an easy guess and checker. So that means I can go right to my signs. I know that there's going to be an x here and an x here, and then I notice that there is a negative first and then a positive. If there's a negative first and then a positive, then my signs are both negative. And how do I know that? I know that because I have this memorized, okay? So let's see. What I need is factors of 56 that are going to add together to get a larger negative, which is going to be a negative 15. Okay, so that actually springs to mind the 7 and the 8, and it doesn't matter where I put it. So 7 and 8, and I am done. Okay, if the 7 and 8 didn't spring to mind, remember factors of 56, I usually make a little factor tree. It's even, right? So if it's even, 2 goes into 56 28 times, but that adds up to 30, not 15. So that's not it. And 1 and 56, that's not it. Okay, 1 and 56, there's 2 and 28. There is also 4 and 7, which means 2 more 2s. So there's a lot of factors of 58, but if you know your factor tables, 7 times 8 is 15, okay? There's 4 and 14. There's a couple of things, okay? But that's my final answer. All right, same with this one, right to the guess and check. That's an x, but because it's a negative, my answer has 1 positive and 1 negative, okay? Factors of 40 that are 3 apart. Those are 39 apart. Factors, let's see, 2 goes in 20 times. No 3s. How about 4 times 10? That's 6 apart. What else goes into a 40? 5 and 8. Oh, that one's 3 apart. So 5 and 8 are my answers, but which one do I put where to get a negative 3 when I foil it back? So that means the larger one has to be negative and the smaller one that. So let's foil it to check. This times this is x squared minus 8x plus 5x minus 40. And like terms, that gives me my negative 3x that I need. So that is correct. Okay. All right. This is a trinomial, 3 terms. There is a x squared and a y squared. This is the proper order when there are 2 variables. There's no greatest common factor to come out. There's nothing that they all have in common to come out. So you're keeping all of those, but you can still go to the guess and check. That's an x, that's an x. But then put the y on the end. And then what are my signs if I have a plus and a minus? If I have a plus, then a minus, that means I have a plus and a minus in my answer. A plus and a minus in my answer. Okay? So then I need factors of 8, 1 and 8, 2 and 4, that are going to what? Subtract to a 2. Subtract. Since the signs are opposite, I need 2 factors of 8 that are 2 apart. So that'd be 4 and 2. And if I want a leftover positive, I need to put the larger number next to the positive. So when I FOIL that, do a quick check, that is 4xy minus 2xy, and that's going to give me a positive 2xy. So that's correct when I FOIL it, okay? All right, look at the next one. These are pretty big numbers. There's a number in front of the x. Does it come out of the rest? Can I take it out as a GCF? Yes, I can. You want to take that out and see what's left. okay? Have to do that. Now it looks like an easy one to factor, so I can go ahead and set this up right here. This is a 6-3 problem. So x and x, and then if there's a negative first and then a positive, it's 2 negatives, according to that chart. And then factors of 8 that add up to a -9. Factors of 8 that add up to 9. That would be the 1 and the 8. And it doesn't matter if I put the 8 here or the 1 here. That would be correct. And don't forget to put your GCF back in your answer, because you need to be able to factor or FOIL this all back and get your original problem. Okay? All right, so the new part for today, reminding people that this is all the chart stuff. You really need to read through that. But as we move on to harder problems, we've been using the guess and check, okay? Or trial and error, whatever you want to call it, when a equals 1. In other words, you don't see anything in front of the x squared. But in 6.4, they're much harder because the number in front of the a term, do you remember what the a term is? Ax squared plus bx plus c. This term here, if that's greater than 1, so you see a 2 or a 3 there or something else, you need to check for GCF, but if it doesn't come out, you need to factor it with it there, okay? So there are many ways to do this. There are a lot of videos about this. I'm going to be teaching it the equation way. Some people call that the grouping way. I use grouping when I'm talking about 4-term polynomials, so I usually say AC method, okay? There are Punnett squares, there are boxes, there are checks. I also like the slide and divide, so I put that in there. There's something called a tic-tac-toe chart. I mean, there's all kinds of things, okay? We need to find something that works for you. I like to suggest the AC method because you're just going to take that, remember that A, and multiply it by the C for any problem, and you're going to get an answer there. Then you're going to get factors of that answer there that are going to add to the middle term. So basically you're taking a 3-term polynomial and turning it into a 4-term polynomial by taking that middle number, that middle term, and dividing it into 2 middle terms. Okay, so you have 4 terms, and you're going to solve it like a 4-term polynomial like we did in 6.2. So let's practice one of these. So your A is 3, your B is 11, and your C is 6. Do we see that? A, B, C. All right. So if you use the AC method, it's A times C. So 3 times 6 equals 18. All right. And then factors of 18 that are going to add up to 11. And I say add up because that's a positive and that's a positive. So my answers are both positive, positive. Okay, so that you can also look at these as being both positive. All right, so this is what I need factors of. So 18 is a 1 and an 18, a 2, a 9, and a 3, and a 6. And I need them to add up to 11, right there, a 2 and a 9, 2 and a 9. Okay, it doesn't matter if I put a 9 and a 2. Just so happens I put a 2 and a 9. So that means I rewrite my original problem, putting this in as an x. Remember, this is what has to add up to a positive 11x, and it does. This is the only way you can mix this up, separate this out. All right, we did that so I can divide it in half and then look at this first half and do a GCF out of there. I'm out of room. I'm going to do it over here. The only thing I can take out is an x. So I have 3x plus 2 left. Let me write this back. 3x squared plus 2x divided in half plus 9x plus 6. All right, so this first half, this half right here, turns into this. X, took an x out, okay? So I go over here and I write 3x plus 2 because this and this have to match. So what do I take out of up here to make sure that it turns into 3x plus 2? Well, I take a positive 3. If I divided a 3 into the 9, I get 3. If I divide a 3 into 6, I get 2. So then the greatest common factor rule says that I need to take out the 3x plus 2 because it's here and here. So I take out one of those and put what's left, this part and this part, together in another set of parentheses. So that's my answer. Okay? If you want to, you can check that to make sure you didn't mess that up. This times this is what? 3x squared. This times this is plus 9. This times this is plus 2, x. And then this times this is plus 6. So there's my 11x back. Yep, it's in a different order, but it doesn't matter as long as it adds up to 11x, and then I get my original problem from that. Okay? Let me do the rest of the next one so I can practice.